This video is over topic 10, number 4 through 7. So this is going to be writing and then solving proportions. So setting up a proportion, you want, it's going to be a fraction equal to another fraction. Each fraction has something that connects it. The things on top have something in common, and the things on the bottom have something in common. The diagonals have like they don't have a direct connection to each other. So first example, we're looking at traveling in an SUV. They covered 228 miles and stopped for gas and filled the tank with 12 gallons. So we're going to assume that they started out with a full tank. And so when they fill it back up with the 12 gallons, that's the amount of gas that it took them to drive the 228 miles. Then they fill it up. Now it's at 21 gallons total, and they have 380 miles to go. So the question is, can they get those whole 380 miles on the 21 gallons in the tank, or do they need to make another stop? And we're assuming the fuel consumption will remain constant and consistent. But like if they've been driving highway, and they may be doing good. Then if there's a lot of city traffic coming up, then they might need more gas to cover that distance. But let's look at, there's a couple different ways. So here we already have the four values. So if we put these into proportion form, we would have 228 miles with the 12 gallons, and we'd have 380 miles with the 21 gallons. So there's several different ways to approach this to say, like, is there enough? One is just to look at the ratios, like what are the ratios for each. So 228 miles divided by 12 gallons is 19 miles per gallon. And to do 380 miles with 21 gallons would it's 18.095, so on. So let's say 18.1. So as long as they're getting at least 18.1 miles per gallon, they can do it, and they're getting 19. So based on that, they should be okay. But let's see, because those are fairly close. Like it wouldn't take a lot of slowdowns and extra traffic to mess that up. So let's see how much wiggle room they actually have. If we want to say we have the 21 gallons, we want to know how many miles that can take them. So we'll take these two equations, set them equal to each other, and just remove the miles. So 228 miles with 12 gallons, and then instead of the 380 miles, we'll put that as an unknown and put the 21 gallons. Then we would do 228 times 21 divided by 12. And that comes out 399. So they could drive 399 miles, theoretically, on that 21 gallons. That means they have an extra 19 miles. So some other considerations potentially would be if the place they're going is kind of way out in the country, in the forest or something, where there's not going to be a gas station within 19 miles. Or maybe they're just really not comfortable getting down to where they only have 19 miles left. The fuel light probably comes on with 30 or so miles to go. Some people fill their tank up if it gets below half. So it just depends how comfortable they are, if they're watching that range that they have left to go, and 19 miles might not be okay. But technically, yes, they can go the 380 miles and almost another 20 miles after that. The other thing to look at is like how much gas would they actually have left if they drive the 380 miles. So we set up again the 228 miles with the 12 gallons and the 380 miles with the now unknown number of gallons. So 380 times 12 divided by 228. And that comes out 20 gallons. So they have 21 gallons in the tank. Theoretically, if it's filled up completely full, this would take 20. So they'd have 1 gallon to go once they get to their destination. Should they plan another gas stop? Probably yes. The calculations, if you're being really just mathematical about it, technically, yeah, they could they have enough. But it's probably safer to stop. How far is a gas station from their destination? Would be something to think about. How comfortable are they with a almost empty tank? That sort of thing. Next example, this is a type that's a bit tricky to set up. So we have fish living in a lake, and then somebody comes and catches 37 of them, tags them, puts them back in the lake. So now there's some fish in the lake with a tag on them. A week later, somebody comes back and catches a bunch of fish. They catch 80 fish and 6 of them have tags. So we're assuming a lot here. Like if I was the instructor of this class, kind of monitoring this project, I would have a lot of questions about this. You know, when they came back a week later and caught 80 fish, like are the ones they caught and released previously, like avoiding being caught now? Are they equally like all over the lake? So what's their actual method? Are they just sitting in one spot catching fish, or are they spread out over the lake? Is it the same time of day, the same weather? All these different things that could make this not work. But the assumption here is that when they caught the 80 fish, that let's say we have the fish in the lake and we have tagged fish and we have fish that are not tagged, and they took like a slice that their 80 fish that they caught is proportional, that it has a representation of tagged fish that matches the representation in the whole lake. So we're saying that the 6 tagged fish out of the 80 that they caught is the same ratio as the 37 tagged fish out of the unknown all fish in the lake. So notice the tagged fish line up with each other. So the significant characteristic for the 37 fish is that they were tagged, not just that they were caught. So the 87 or the 80 that were caught, the significant there is that they're a total. So the 37 lines up with the 6, not with the 80. If you line the 37 up with the 6, because you can probably tell that the 80 and the 6 go together. But if you put the 37 here, if you put the 37 here lined up with the 80, then you would get a much smaller number, and that would not be correct. It would hopefully be obviously incorrect to answer how many fish live in the lake altogether, because we know that number has to be bigger than 37, it has to even be bigger than 80. So if you got something smaller than 37, that would be definitely wrong. So we're going to do 80 times 37 divided by 6. And that comes out 493 repeated. So round that off to 493 fish. And if I was in charge of this project, I'd probably say you need to go back like every week for 8 weeks or 10 weeks or something and do this over again and see. Like maybe one week you catch 80 and 6 are tagged. If another week you go and catch 80 and 30 of them are tagged, like that would raise questions. If every time you catch around 80 fish, there's about 6 tag, like if it stays consistent, then you can be more confident that this is accurate. Then the next example we have, and these two examples are similar, where you have a ratio and then you have something else that is related but not quite part of that ratio. So if I put my 3 green apples and my 5 red apples in a fraction, and then I say I want to know how many are red, so I'm going to put unknown red. The 24 apples are not green apples. So I cannot put the 24 here lined up with the 3 because the 24 is not green. So if I want to have the 24 in the bag, I'm going to have to line that up with something to do with the 3 and 5 that relates to that. So 24 is the total of the red and the green in the bag. So I need to match that up with the total of the apples in the ratio. So 8 total. So my ratio to solve how many red in the bag is 5 out of 8 equals x out of 24. 5 times 24 divided by 8 is 15. And similarly, number 7, we have the ratio of union to non-union. And that ratio is 5 to 7. And then we have 312 employees total. So this is the ratio. And then we have in the whole company, we have 312 total. So we need a total to do with the ratio, which is 12, 5 plus 7. And we want to know how many union members. So this is the thing that we're looking for, line up with the 5. So I can put this into a fraction. Excuse me, 5 over x equals 12 over 312. Setting up a proportion, by the way, there's 8 different correct ways you could set up any given ratio. There are also ways you could set up that would not be correct, but there's not like a one right way to set it up. This is going to be 5 times 312 divided by 12. 130.